What up, everybody? Instructabeats back again, here with another awesome math lesson. Today we're going to be talking about finding the least common multiple and greatest common factor by using a Venn diagram. So let's dive in and see what our objective is today. Our objective today we'll be able to find the least common multiple, sometimes we call that the LCM, and greatest common factor, or GCF, of two numbers by using a Venn diagram and our prime factorization knowledge. Previously on Instructabeats. Alright, so previously on Instructabeats, we've covered these topics. We're not going to spend a lot of time here, but a factor is a number you can multiply with another number to get a product. Kind of wordy. I'll give you an example in a second. And a multiple is a number you get when you skip count or multiply by a number. So let's take a look at 12, right? So my factors of 12 are numbers that I can multiply together to get 12. So 1 and 12, right? 2 and 6, 3 and 4. And a lot of times you might see them in a little factor rainbow here, right? These are numbers you can multiply together to get 12. Now multiples of 12 are going to be numbers that we can use 12 and multiply or skip count and land on. So our first one would be 12. That'd be 12 times 1, right? Then 24, 36, 48, 60, and the list can go on, right? Matter of fact, you can go on forever for multiples. So I just kind of wanted to spend some time there, make sure we understood what a factor was and what a multiple was. And if you need extra help on that, check out our other videos. Let's get into our math vocabulary for today. All right, so our math vocabulary today, greatest common factor. Well, if you understand what factor is, this probably makes sense because common means something that is the same. So the greatest common factor is the greatest number that is a factor for all of the numbers you choose. So today we're going to be talking about two different numbers. So we're going to find the factors of each of those and what's the biggest or greatest factor that they have in common. The least common multiple, okay, is going to be the smallest number that is a multiple of two or more numbers, okay? So the numbers that we're choosing, if we listed our multiples out, what is the smallest number that they have in common for those multiples? All right, so let's go to the lab to check out an example. So I want to give you an example, right? A concrete example, although don't eat concrete because that would hurt, all right? If we want to find the greatest common factor in the least common multiple of 18 and 12. So 18 and 12 are two numbers, and we're going to use, because these numbers are kind of small, we're going to use what I call the listing strategy. That's when we list out the factors of 18 and the factors of 12, and then we just look at them and say, hey, what's the biggest number they have in common? And then we do the same thing for the multiples, and then look for, hey, what's the smallest number they have in common? So if the numbers are small and you know the factors of them without having to think too hard, the listing strategy is a great strategy that you can use today. So factors of 18, right? We have 1 and 18. And then we have 2 and 9. There we go. And then we have 3 and 6. Okay, use my commas right there. Factors of 12, we just talked about those, right? That'd be 1 and 12, 2 and 6, 3 and 4. All right, and if we're looking at this list, which ones do they have in common? So they have 1 in common, okay? They have 2 in common. They have 3 in common. They have 6 in common, and that's it. So out of those common factors, what is the greatest or the biggest? And that, of course, would be 6. So my greatest common factor of 18 and 12 equals 6. All right, so that's how I can use my listing strategy here. All right, multiples of 18 and multiples of 12. I'm going to start with multiples of 12 because sometimes the least common multiple is actually one of the numbers. All right, but so multiples of 12, we have 12, 24, 36, 48. We'll just stop there. Let's do 18, 18, 36. Wait a minute, I see one right here that they already have in common, okay? So the least or smallest common multiple of 18 and 12 is 36, all right? So you'd say LCM equals 36. So this is just a quick concrete example using the listing strategy. But some of you might have a very important question. What happens if the numbers are big and I don't already know the factors or multiples? Like what about 78 and 26? How would I do that? Right? I don't want to list out all the factors of 78 and 26. So let's go back to the lab to take a look at how we can do this. All right, so for bigger numbers like these, okay, I like to use what I call the prime factorization method, and that's when we're going to use the prime factorization of each of these, and then use a Venn diagram to help us organize them, to help us figure this out, right? So first of all, what is the prime factorization in expanded form? Okay, you can do exponential form when we have a lesson on how to do both of these, but expanded form makes it a little bit easier for me so I don't make a mistake. So I have 78 and 26. The prime factorization for 78 is 2 times 2 times 13, and the prime factorization for 26 is 2 times 13. I'm going to draw my nice Venn diagram over here, and on this side I'm going to have 78 in red, and on this side I'm going to have 26 in yellow. Red and yellow make purple, at least I think they do. So we're going to list the prime factors that they have in common right here in the middle in purple. So see that both of them have a 2 and a 13. So in common, I'm going to put 2 here, okay, comma, 13, all right? So I'm going to cross those off, and this is why I write it in expanded form so I can cross it off easily. Now, the only thing I have left over is my 3, and my 3 is for 78. I didn't have anything left over for 26, so here's my Venn diagram of how I've organized the prime factors of both of these. Now, the really cool thing is to find the greatest common factor, all you do is look at the prime factors they had here in common, and we're going to multiply the numbers that are here. So 2 times 13 would be 26. So my greatest common factor for these is 26. To find my least common multiple, okay, what I'm going to do is I'm actually going to multiply all the numbers in my Venn diagram. I'm going to find the product of 3 times 2 times 13. And when I multiply 3 times 2 times 13, I'm going to get 78, all right? So this is one's kind of funky because actually the greatest common factor is 26 and least common multiple is 78. That typically doesn't happen, right? But that's okay. This is how we can use our prime factorization, our Venn diagram, to quickly find the least common multiple and greatest common factor. Now, I did a lot of stuff right there. So let's take a look at the steps we can use for doing the Venn diagram. All right, so step number 1, find the prime factorization in expanded form is what I do for each number you are starting with. Once you do that, step number 2, fill out the diagram by putting the prime factors in common in the middle, and then the other prime factors in the correct spot, right? So just like I did. Now, step number 3, to find the greatest common multiple, this one's very easy. Multiply the prime factors that they had in common, right? That part in the middle of the Venn diagram. And number 4, to find the least common multiple, multiply each number you have in the Venn diagram, all right? So these are 4 quick steps. Go ahead and pause video, write those down, and then let's take a look at these steps in action in our we do problem. All right, here's our we do problem, right? We want to find the greatest common factor and least common multiple of 124 and 152. Again, these are not small numbers, so I'm not going to use my listing technique. I'm going to use my prime factorization with my Venn diagram. To make this quicker, I'm going to give you the prime factorization in this lesson, all right? If you don't know how to find the prime factorization of a number, check out our prime factorization with the factor tree lesson. I like to use a factor tree, but there's other ways to do it. So any way you know how, find the prime factorization, and we're going to use that today. So the prime factorization for 124 is 2 times 2 times 31, and the prime factorization for 152 is 2 times 2 times 2 times 19. Again, I write that in expanded form so I can cross out the numbers. All right, so step number 2, right, was to write down the prime factors they have in common. So I see that they both have a 2, and they both have another 2. All right, so I'm going to put 2 and 2, okay, because these two go together, it crosses those out. These two go together, that crosses that out. Now, again, I'm not writing down 4 2's in here, right? I'm writing them down twice because there was 2 2's that they had in common, right? So I only write those twice. So left over for 152, I had a 2 and a 19. So I'm going to cross those out. And then left over for my 124, I had a 31. Now again, the greatest common factor is probably the easiest one. It's not easier, it's just quicker, right? So I'm going to multiply the prime factors that they had in common. 2 times 2 is 4. So even for these large numbers like 124 and 152, the greatest common factor was 4, right? Now, the least common multiple, To find that, if you remember, step number 4, I need to multiply all of the numbers in my Venn diagram. Okay, so I need to multiply 31 times 2 times 2 times 2 times 19. You can do that on a calculator if you'd like. And when you do that, you're going to get a least common multiple of 4,712. That's why I don't want to use the listing strategy for that, because I would have had to list out 124 and keep repeatedly adding it all the way to 4,712, and that would be ridiculous. So I use my prime factorization and my Venn diagram to make it a little bit quicker. All right, so our U-try problem, we're going to do the greatest common factor and least common multiple of 42 and 126. So in a second, you're going to pause the video, try it, and then push play to check your work and see how you did. If you're not ready to do one by yourself, that's all right. You can do it as another we do problem. Just keep rolling the video. But if you're ready to try it by yourself, go ahead and push pause right now and then push play when you're ready to check it. All right, so hopefully you just paused it and at least tried it, right? So the greatest common factor, least common multiple, I need to know the prime factorization for both of these numbers. So the prime factorization for 42 is 2 times 3 times 7. And the prime factorization for 126 was 2 times 3 times 7. All right, so now I need to do my Venn diagram. So next thing I need to do is find the pairs of prime factors that they have in common, right? So I have a 2 and a 3. Okay, these were in common. And then I also have a 7, okay? I had nothing left over for 42, but I did have 1 3 left over here. So to find the greatest common factor for 42 and 126, I need to multiply my prime factors that we had in common. So 2 times 3 is 6, 6 times 7 is 42. So the greatest common factor would be 42. And the least common multiple would be 2 times 3 times 7 times 3, right? Because I'm going to multiply all the numbers in my Venn diagram, and I'm actually going to get 126. So my greatest common factor is 42. My least common multiple is 126. All right, if you got that one right, that is awesome. But now, welcome to the challenge zone. It's time for the challenge zone, okay? So now we're not going to do 2 different numbers. We're going to do 3 different numbers. What is the greatest common factor and least common multiple of 9, 27, and 33? Okay, I love for you to use your prime factorization. These numbers are small. You could also maybe even use your listing method, but go ahead and try the prime factorization as well. Go ahead and pause the video and then push play when you're ready to check your work. All right, so hopefully you just paused it. Okay, so we need to know what is the prime factorization for 9, for 27, and for 33. All right, so my prime factorization for 9 would be 3 times 3. My prime factorization for 27 would be 3 times 3 times 3. And my prime factorization for 33 would be 3 times 11. Now, I'm not going to have a Venn diagram with 2 circles. I'm going to have a Venn diagram with 3 circles. So if you got that one right, go ahead and pat your back. That is awesome. So this gets a little funky right here. All right, there we go. So they all had a 3 in common. So in this middle part, I'm going to put a 3, and I'm going to cross that out, okay? 27, oh, sorry, I should have just done 9, 27, and 33. So 11 wasn't in common with anything else. I'm going to go ahead and put that down there, okay? I did have a 3 in common between 27 and 9, so let's go ahead and put that one right there, all right? And then I had a leftover 3 in my 27. So to find the greatest common factor, I need to look at the part of my Venn diagram that they all had in common and multiply those together. But if there's only one, like right here, 3 was the only number they all had in common, so 3 is my greatest common factor. My least common multiple, I'm going to follow the same rule. I'm going to multiply all the numbers that I have, okay, together. So 3 times 3 times 3 would obviously be 27. And then 27 times 11 is going to make the least common multiple of all 3 of these 297. All right, so hopefully you got that one right. If not, don't worry about it. It's okay to fail as long as you learn from it. Thank you so much for checking out Instructabeats. We really appreciate you spending your time with us. We know there's lots of different options online. Check out Instructabeats.com and for all our other videos, resources, songs, and merchandise. We'd love for you to subscribe, leave a comment, let us know where you're watching from. Again, thank you so much. Instructabeats out.